My name is Megan Daly.
My name's Aiden Bob.
Today, we are testing a claim for chi-square test for association, which can be found in Chapter 10 in Section 4 of your textbook. Our null hypothesis, H of O, is that there is no association between gender and type of lunch, lunch from home, or lunch from school. Our alternate hypothesis, H of A, is that there is an association between gender and type of lunch, lunch from school and lunch from home. The significance level we will be using today is 5%.
To test our hypotheses, each of us went into one of the lunchrooms and observed groups of people. We collected their gender and made a tally for which type of lunch they had with them in the appropriate box. We collected this simple random sample of 200 people. This was as random as the lunchroom and table people chose to sit in each day was randomized, and the tables we observed were chosen without bias.
To make sure we can conduct this experiment, there are two different tests in making sure that we can do so. The first test we used was a simple random sample test. We confirmed that this test was passed by making sure that we randomly selected our 200 people and did not use any sort of bias. The second test we had to conduct was the large counts, making sure all expected values were larger than 5. This test was confirmed as well.
The image, as shown on the screen, is our table with our findings or our observed counts. 27 people of the 200 we observed brought lunches from home. The other 173 brought lunch from the school lunch line. Out of those 27 people, 14 were girls and 13 were boys. Out of the 173, 81 were boys and 92 were girls. But what does this say about our hypotheses? First, we have to find our expected count value.
To find the expected count values, you would use the observed table. You would set it up the same way and have the L shape that represents the total values from the observed table the exact same. For each of the 4 squares, you will times the total value for the row by the total value of the column and divide it by the overall total table value. For the quadrant dealing with mail and lunch from home, you would use the row value of 27 and multiply it by the column value of 94 and then divide it by 200. This produces a value of 12.7. For the quadrant of female and lunch from school, you would multiply the row value of 173 by the column value of 106 and divide it by 200, producing a value of 91.7.
You would do this for the other 2 quadrants as well, producing a value of 14.3 in the female and lunch from home quadrant and a value of 81.3 in the male and lunch from school quadrant. The values in the first column should add up to be 94, and the values from the second column should add up to be 106. The values in the first row should add up to be 27, and the values in the second row should add up to be 173. Our expected counts table.
Since our conditions are met and our tables are calculated, we now have to find P. To find P, we will first have to calculate our degrees of freedom. To find our degrees of freedom, we will use this formula. dF is equal to the number of rows minus 1 times the number of columns minus 1. Since we have 2 rows and 2 columns, our degrees of freedom is 1. Using a calculator to calculate the chi-square value is the fastest and easiest way. To do so, you would go to the Stat button on your calculator, go to Test, then go to chi-square goodness of fit test. Then enter in your observed and expected counts in List 1 and List 2. Once doing so, you'll enter in your degrees of freedom. We've determined that our chi-square value is 0.015. Looking at Table C to locate the p-value, we used our chi-square value and degrees of freedom to find that our p-value was larger than 0.25.
Because our p-value of 0.25, or 25%, is bigger than our significance level of 0.05 or 5%, we fail to reject HO. There's no association between gender and type of lunch from home or lunch from school.